Well, good morning. This is Chrissy McMahon, and you're listening to Alchemical Connections. Thank you for being here on awakeradio.co.uk and shizizradio.com. We're simulcasting on both stations, and we have lots of wonderful changes and happenings at both stations, and hope you can check us out. We're a 24/7 operation, and you can check out our sister website at awakeradio.us. This morning on Alchemical Connections, I'm calling it the Fukushima update, but I think I should call it Fukushima current events. We're going to have a lot of pods, a lot of different information, so here we go. We're just going to get right into it. Thank you for listening.
The operator of the Fukushima Daiichi nuclear plant has detected a record level of radioactive cesium in groundwater. It was found in water samples taken from a newly dug well about 50 meters from the ocean. Now, Tokyo Electric Power Company workers detected 54,000 becquerels per liter of cesium-137 in the water. This is 600 times the government standard for radioactive water that can be released into the sea. And it's more than 30,000 times the level found in water samples taken from a nearby well last week. TEPCO officials believe the radioactive water is leaking from an underground tunnel that extends from the reactor buildings toward the ocean. They say they've been taking measures to prevent the tainted water from reaching the sea, but have yet to determine the exact source of the leak.
4. Sentenced to 35 months for nuclear break-in. An 84-year-old nun was sentenced to 35 months in prison Tuesday for breaking into a nuclear facility, her lawyer said. In May, a federal jury in Knoxville, Tennessee, found Sister Megan Rice, Greg Boertje-Obed, 57, and Michael Walli, 63, guilty of destroying U.S. government property and causing more than $1,000 in damage to federal property. It was not immediately clear what the sentences were for the two other peace activists. The incident began before dawn on July 28, 2012, when the three cut through a chain-link fence surrounding the Y-12 National Security Complex in Oak Ridge, Tennessee. They then walked nearly a mile, cutting through three more fences and breaching what was supposed to be the most tightly secured uranium processing and storage facility in the country. It was not until hours later that a guard finally confronted the activists who, by then, had hoisted banners, spray-painted messages and splattered human blood on a building that houses highly enriched uranium. They're at peace about this. They're peacemakers, and they knew that they risked this, Joe Quigley, attorney for Walli, told CNN affiliate WATE in May after their trial. Nobody is happy to go jail, but they understand. In response to the incident, Congress has held a series of hearings and issued security recommendations to the Department of Energy and its National Nuclear Security Administration, which runs Y-12 and 7 other nuclear weapons sites. In March, Deputy Energy Secretary Daniel Poneman testified before the House Energy and Commerce Committee that the Department of Energy had taken several major actions to improve security since the breach, including management changes.
Today, Senator Ron Wyden of Oregon called for an investigation after a second whistleblower was fired from the cleanup at the Hanford Nuclear Reservation in Washington State. We first spoke with her last year when she raised concerns about the project. Hanford is filled with radioactive waste from building nuclear bombs. Here's Carter Evans.
For the last 5 years, Donna Bushy was manager of environmental and nuclear safety at the Hanford Nuclear Reservation. She was fired on Tuesday.
I think they were retaliating against me for my ongoing outspokenness.
In 2010, she warned supervisors and regulators about design flaws that she says could lead to a radioactive explosion at Hanford. The $13 billion government project will dispose of 53 million gallons of nuclear waste. Bushy worked for subcontractor URS.
The senior URS manager told me, with no introduction, that I had behaved unprofessionally or had professional misconduct, and I was terminated for cause.
When you got your walking papers, were you surprised?
Shocked.
We spoke with Walter Tamasitis shortly after he was fired last fall. The nuclear engineer told Congress in 2011 about the risks at Hanford.
Construction was halted because of safety concerns.
Yes, sir.
The safety concerns that you raised.
Yes, sir.
Tamasitis said URS told him he was fired due to cutbacks. URS declined our request for an interview, but in a statement said URS encourages its employees to raise concerns about safety. The company claims there was no retaliation, and Ms. Bushy's employment was terminated due to issues unrelated to her purported concerns.
Summarily removing me from the project sends a clear and present message to the employees that if you speak up, if you stand up, you will be terminated.
She's now planning a wrongful termination suit. Carter Evans, CBS News, Los Angeles.
Active isotopes. What is an isotope to begin with? An isotope is something that, well, you can call something an isotope if it's got the same number of protons, but a different number of neutrons. So we've got same number of protons, different number of neutrons, same number of protons, means it's the same element. Different number of neutrons mean it's going to be a different mass number. So here are some standard ones. Hydrogen 1, that's just got a proton, and that's standard hydrogen. Hydrogen 2 is called deuterium or heavy hydrogen, and this occurs in the ocean very rarely, but commonly enough that people say there's enough deuterium in the ocean to supply our energy needs for millions of years if we are able to do fusion properly, which we are not yet, but we'll see. Then there's hydrogen 3. So this is a proton and 2 neutrons. This guy is unstable, unlike these two, and they are both stable isotopes of hydrogen. This guy, which is called tritium, is very important in thermonuclear devices and in fusion studies, and he decays in about 12.32 years, and that's the half-life into helium-3, an electron, and an antineutrino. Now, most of the time, of course, if we're going to do this reaction, we'll want to put it in the bottom numbers. And so we've got 3 equals 3 plus 0, plus this guy's got to be 0. 1 equals 2 plus 1, plus this guy's also got to be 0. So for that reason, I mean, it doesn't have any change. It doesn't have any mass. So it doesn't really interact with any of the nuclear reactions. And so most of the time, chemists won't even write it, that guy. But he's there, all right? So we've got electron. And this is called an electron antineutrino, all right? Whatever. So these are some standard isotopes. We would say that this is a radioactive isotope of hydrogen, and these two are the stable isotopes of hydrogen. Some other important stable isotopes are lithium-6 and lithium-7. Both of these occur naturally in lithium. This one actually made a big deal in the biggest thermonuclear device, biggest hydrogen bomb that the United States ever set off. And this was in 1954, and it's called the Castle Bravo explosion. It was supposed to be about 5 megatons, but instead it ended up being 15 megatons, mainly because lithium-6 was used to make a solid lithium deuteride fuel for the thermonuclear reaction. They didn't think that the lithium-6 was going to participate in the reaction, but it actually did. Anyway, alright, so let's look at some standard radioactive isotopes. Alright, uranium-238. That consists of the majority of the uranium that's found on the Earth. It has a half-life of 4.5 billion years and decays via alpha emissions. Uranium-235 is the big fissile. Fissile meaning I can use it in a nuclear reactor or in a nuclear bomb, isotope of uranium. It's the one that we want. So if you say enriched uranium, it means that its uranium-235 content is much, much, much higher than that found in mined uranium. Now one of the reasons that uranium-235 is so rare in nature is that its half-life is only 700 million years, whereas the half-life of uranium-238 is 4.5 billion years. So this is about the age of the Earth. Many half-lives of uranium-238 have gone by in the lifetime of the Earth. So that means that a lot of the uranium-235 that was present originally when the Earth formed is now gone. It has decayed into thorium-231, alright. Thorium-232 is another very, very, very commonly found radioactive isotope on the Earth. This consists of the majority of naturally occurring thorium in the Earth because of the half-life of thorium-232 is about 14 billion years. He also decays via alpha emissions. Plutonium-239 is a very important isotope when looking at nuclear plants and when looking at nuclear bombs. The reason plutonium-239 is very, very important is that it's fissile, and that means that you can take a neutron, shoot it at this plutonium-239, and be almost certain that he'll fission and split off some other neutrons and get going this chain reaction that we need to get going in a nuclear reactor. His alpha decay is 24,000 years. That means that he cannot be naturally occurring. Too many half-lives have gone by since the beginning of the Earth for there to be any plutonium-239 left over, even if there was any when the Earth formed. So where do we get plutonium-239? Well, we get it by making uranium-238 undergo a nuclear reaction. We shoot neutrons at it that are slow-moving. It will accept some of them because uranium-239, and a couple of days later, that will have decayed into plutonium-239. And we'll have what we want, alright? What about radium-226? Radium-226 is a dangerous isotope. It appears in the uranium chain. So all the uranium that exists that has this half-life of 4.5 billion years, well, it's going to decay at some point, and somewhere on that chain you get radium-226. Radium-226 is a type of radium that was originally isolated by the Cries in the late 1800s, and this guy has a half-life of about 1,600 years. So you can purify it from uranium ores, alright? Then there's radon-222. That's the guy that you may have heard of if you've heard of radon poisoning in basements in the East, and it's because of the uranium that's present in bricks that will decay, and eventually on the decay chain we get this radon. Radon is a gas. That means that when you get this radon, it's just going to seep out of the bricks and you can breathe it in. You don't want to breathe it in, though, because if you do, the alpha decay is about 3.8 days, and those alpha decays, while your skin will stop them, your organs kind of won't, alright? So if you breathe it in, or if you eat an alpha emitter, not so safe no more, alright? So let's look at the more dangerous guys. Carbon-14 is a beta emitter. His half-life is about 5,700 years. This guy actually occurs naturally in nature because of cosmic rays coming from the sun and their interactions with nitrogen and oxygen in the upper atmosphere. That will generate carbon-14 for us. Potassium-40, also a beta emitter, also is naturally occurring. His half-life is about 1.25 billion years. Strontium-90 and iodine-131 are both byproducts of nuclear fission reaction. So if you've got a nuclear bomb that goes off, you're going to have a lot of strontium and iodine-131 in the air right after the nuclear reaction. Now these guys are talked about a lot because they are beta emitters with appreciable half-lives, and also because strontium and iodine will both be absorbed by the body and will be just held by the body. Strontium because it looks to the body like calcium, and iodine because our bodies collect iodine in the backs of our brains. Now ordinary calcium, ordinary iodine would be fine. I mean, okay, your body collects it for a reason, but strontium-90 is radioactive. His half-life is about 29 or 28.9 years, and that means that if you just take it in and your body says, ooh, this is good, let me use it to replace calcium in the bones, that's not good, because when he decays, just sitting there inside your bones, that beta is just an electron moving very, very quickly, and he's going to go through and wreak havoc into your cells. Same thing with iodine-131, 8-day half-life. And so these things we want to avoid. And this is one of the big problems with nuclear fallout from nuclear bombs. And then the last guy is polonium-210, which is an alpha emitter. Half-life is 138 days, and you may have heard of polonium-210 as a radioactive isotope that killed the Russian spy. So these are radioactive isotopes. This was recorded from an article.
Hi, I'm an average guy, just like you. A good old American. I've heard a lot of scuttlebutt on the wireless lately about something called Fukushima. People are worried about radiation. Well, the good scientists who are in charge of this sort of thing have it all figured out. They want us to know that we're perfectly safe. Sure, there's been a problem in Japan, but the Japanese authorities are taking care of it. Now, some of those fearmongers on the internet are telling us to be afraid of radiation. They say that radiation can hurt us. But the sun is radioactive, and so are bananas. But we have a right to know, so let's learn a little about it. It's easy to understand radiation. Let's go on the internet and read an article from MIT, the Massachusetts Institute of Technology. They'll steer us right. One gray equals 100 rads. A rad is 10 milligrays. A sievert is 1,000 millisieverts, or 1,000,000 microsieverts. A sievert is 100 rems. A becquerel is 1 count per second. 1 curie is 37 billion becquerels, or 37 gigabecquerels. For X-rays and gamma rays, 1 rad equals 1 rem equals 10 millisieverts. For neutrons, 1 rad equals 5 to 20 rems, depending on energy level, which equals 50 to 200 millisieverts. For alpha radiation, helium-4 nuclei, 1 rad equals 20 rems equals 200 millisieverts. Gosh, that was easy. I wish we had done that sooner. No need to be afraid of radiation. Just remember these simple tips from MIT. And remember, official stories exist to protect officials.
March 2011. An earthquake off the coast of Japan triggers a deadly tsunami, killing more than 15,000 people. Waves swamped Tokyo Electric Power Company, or TEPCO's, Fukushima Daiichi nuclear power plant complex. Huge explosions followed, and ultimately meltdowns of 3 of the 6 nuclear reactors, spewing radioactive material into the atmosphere. Into this unknown sailed the USS Ronald Reagan, an American nuclear-powered supercarrier with more than 5,000 sailors and Marines on board. The carrier was a key part of the U.S. Navy's Operation Tomodachi, the Japanese word for friends. And now, 3 years later, more than 70 sailors and Marines from that mission have filed a $1 billion lawsuit against TEPCO, alleging the company withheld information that led to radiation exposure, causing illness, even cancer. Medical experts are skeptical of a connection, but the cases are heartbreaking. Lindsay Cooper and Kim Geiseking both served on the Reagan and said since they've gotten back, they face debilitating thyroid issues. Thomas McCants was on the USS Germantown in July 2011 when it responded to Japan. When he returned, he told CNN he was diagnosed with leukemia. And then there's Navy officer Steve Simmons, who served on the Reagan. Before he set sail, he was an avid hiker in the mountains of Hawaii.
What was your health like in the months leading up to deployment?
The summer of 2010, when we pulled into Hawaii, I was actually out doing trail runs. A couple days later, I went and hiked Diamond Head, and the following day from Diamond Head, I actually went and hiked Stairway to Heaven.
But Simmons says something happened to him off the coast of Japan. A year after returning to the U.S., he lost all function in his legs.
What do doctors think is wrong with you?
No idea.
They don't know.
They have no idea.
2 moments during his deployment stick out to Simmons. At one point, the ship stopped taking in water from the sea and purifying it because of contaminants. He had already had some of it to drink that day.
The water feeds everything. The showers, the water faucets, the soda machines.
How serious is it when water has to be secured because they picked up contaminants? Had that ever happened to you before?
Yep, this was a first. I think this was a first for everybody on board.
The Reagan also sailed through the post-meltdown nuclear plume for hours, leading to this thorough decontamination. The ship locked down the ventilation system, Simmons said. That account fits with the prior reporting by CNN's Bill Weir, who tried to get on the ship for a story and was waved off by commanders citing radiation concerns. The Navy declined our interview request because of the pending litigation, but in a statement, a spokesman said, quote, "There is no indication that any U.S. personnel supporting Operation Tomodachi experienced radiation exposure at levels associated with the occurrence of long-term health effects." The Navy acknowledged the ship sailed through the nuclear plume, but disputed a key point in the lawsuit. The complaint alleges that the Reagan was operating 2 miles off the coast. The Navy told CNN repeatedly the Reagan was operating approximately 100 miles out to sea. There was great concern from the Navy. CNN's Martin Savage was on board the Reagan during part of its month-long deployment. His team, like the sailors and Marines, went through constant radiation testing and decontamination after being on deck.
When your superiors tell you, okay, we secured the ventilation system, or we can go back to using water from the ocean, it's safe now, how confident are you that everything is okay?
There was some misleading information that was given, not from the standpoint of Navy or DOD. That information that we were using to make decisions was all being fed from Japan and TEPCO.
In response to our questions about the suit, the power company issued a statement thanking the U.S. for its aid, but adding, quote, "We withhold any comments on this lawsuit, and we will take appropriate measures in accordance with the judicial procedures in the United States." TEPCO has until April to respond in court. There is no question Simmons' health has radically deteriorated since his time on the Reagan. But why? Cham Dallas, the director of the Institute for Disaster Management at the University of Georgia, is a respected radiation expert who has led 7 expeditions to Fukushima.
I think that there was probably some exposure to radiation on the USS Ronald Reagan, but saying some manifests to many people that any exposure to radiation is going to be dangerous. That is actually not the case.
Dallas said the Navy's calculations suggest the radiation exposure of the sailors and Marines was about the same as taking a transatlantic flight, or not very much. He says health effects from radiation, such as cancer, take years or even decades to show up. For Dallas and other experts CNN consulted, these illnesses have happened too soon to have been as a result of the exposure at Fukushima.
You have an exposure to radiation, and then there's a pause. There's a certain period of time before the health effects start to come.
So what is the reason dozens of sailors and Marines exposed to radiation are having these health problems? Does the Navy and do these experts know everything that went on at Fukushima? Getting to the truth cannot come quickly enough for Steve and Summer Simmons.
Let's say there's somebody watching this report and they say, look, I'm really sorry that you're going through what you're going through, but the Navy and the Pentagon don't think that this is related to Fukushima, so maybe this isn't related at all. What would you say to them?
Time will tell.
Steve Simmons and his wife Summer, like the 78 other plaintiffs, hope time will bring compensation from TEPCO, or, at the very least, more information. Until then, the Simmons family is trying to cope as best they can, going so far as to reshoot the memories of their big wedding day, so those pictures are no longer a reminder of what once was.
We retook our wedding pictures to include the chair because we wanted to be able to look forward instead of looking back, and we wanted our wedding photos to be what we are.
Simmons is in the process of being honorably discharged from the Navy for medical reasons. He continues to wait for a diagnosis so he and his family can sort out what their next step should be. The budget bill that Congress passed last month demands that the Pentagon provide Congress a full accounting for the health of all those who serve
suing TEPCO, the company in charge of the stricken Fukushima Daiichi nuclear power plant. At least 71 sailors on the USS Ronald Reagan have reported radiation sickness, and they're suing TEPCO, alleging that the company knowingly downplayed the dangers of nuclear radiation at that Fukushima site. Of those 71 sailors, at least half now have some form of cancer, according to the lawyer representing them. And other sailors are dealing with thyroid and reproductive health problems. So did TEPCO knowingly mislead the world about the radioactive dangers at Fukushima immediately following the devastating tsunami? And could this lawsuit be the first of many to come? Joining me now for more on this is Kevin Camps, radioactive waste watchdog at Beyond Nuclear. Kevin, welcome back.
Thanks, Tom.
It's always nice to see you.
Thank you.
So what's the story? I think I've seen absolutely no coverage of this in any American media. So first of all, is it actually real that the soldiers aboard the USS Ronald Reagan off the coast of Japan when Fukushima melted down were exposed to high levels of radiation?
Well, it's a shocking story, and I first learned of it last March 11th, which was the second anniversary of the Fukushima catastrophe beginning in 2011.
So they had kept this buried for 2 years?
Two of the sailors came to a big gathering in New York City to mark the anniversary, and they were suffering health effects from their service on board the Reagan. Turns out that the Reagan was anchored just a mile or two off of the Fukushima Daiichi nuclear power plant during the worst of the radioactivity releases, which was news to me. I mean, I follow this as closely as I can. 2 years into this thing, I find out that the Reagan was that close to these catastrophic radioactivity releases. So the crew on board that ship, 5,000 plus sailors, were in harm's way for several long days on end. Not warned by TEPCO, not warned by the Japanese government, not warned by the United States government, which had radiation detecting planes flying all over northeastern Japan. So,
well, you would think that an aircraft carrier in this day of dirty bombs and you know that they would have radiation detectors on the ship.
Well, some of the first news that was really disturbing in the first days of Fukushima Daiichi was that the aircraft carrier detected radioactivity on the helicopters coming back, landing on board the flight deck. And so one of the sailors who's now stepped forward in a big way was servicing those helicopters. Another of these sailors that I met in New York, his name is Maurice Ennis. He set off the radiation monitors below deck when he came down from being on the flight deck. So there were lots of indications that there was something seriously wrong, but they stayed in this contamination plume for days on end. So they were getting the radioactive gases, which they were breathing in. They were getting the fallout onto them, so they're being exposed that way. What I didn't realize until this latest news about the relaunch of this lawsuit against Tokyo Electric, even the water that the sailors were drinking was from their desalination system. So they were getting the seawater that was contaminated with radioactivity. It was being desalinated by the ship, and they were drinking it, they were cooking with it, they were showering with it. Wow. But those desalination processes don't take out the radioactivity.
Right, because salt is a fairly large molecule. It's sodium and chloride, and if you've got just an individual atom as opposed to a molecule or a particle, the desalination is not going to take it out. Right?
You need special filters. You can't get tritium out of water, period. Not at industrial scale.
It's small.
It is water.
It's helium.
Yeah. It's hydrogen. It's radioactive hydrogen. Yeah. You need special filtering to get out the cesium, to get out the strontium. None of that was taking place. So that ingestion pathway combined with all the others could account for some of these health effects we're seeing.
So what's the, has the government stepped up and done anything? Are they testing the 5,000 soldiers, or is it just these 71 who are sick who are suing? I mean, what's the deal?
Well, the common story I keep hearing from these sailors who are, stepping up and speaking out is they don't even have health care. I'm not sure what's going on, but they're kind of on their own resources. Most have had to leave the service because of debilitating health conditions. So they seem to be in, desperate straits. They're looking for, some funding to help them get the health care that they need.
Senator Sanders is the chairman of the Veterans Committee. Somebody, you should bring that to his attention. I'll try to do so tomorrow. He's going to be on our show. We just have 90 seconds here. I'm wondering what's the, we've heard that Reactor 3 has got steam coming out of it. We were reporting today on our radio show that it's not, it doesn't seem to be an immediate crisis. What is going on?
Well, I think Arnie Gunderson at Fairwinds has explained it well. It's the weather conditions that make the steam visible. But what people need to realize is that we're almost 3 years into this thing. Those releases are happening every day. Those releases atmospherically...
It's just that when it gets cold enough, you see it.
You see the condensation. Yeah. But those releases into the ocean are happening every day. They have been for 3 years. So that is the massive radioactivity release that's going on. Once in a while it becomes more visible because of atmospheric conditions that you would see, you see your breath when it's cold outside. Right. So we're seeing this heated water coming out of Unit 3. It's just the tip of the iceberg.
And Unit 4, the one that was listing that had all the rods up at the top, that they were going to start taking those rods out, pulling the cigarettes out of the broken, crushed pack. Yeah. How's that going?
Very little reporting, which is kind of scary, actually. So one would assume that without the reporting that it must be going smoothly, but I'm not sure that that's the case.
Maybe it's not going at all?
We don't know. We hear very little about what's going on.
And the stories about the Japanese mafia hiring homeless guys to clean this site up, is that true?
You know what's incredible? Yeah, it is true. Is this new State Secrets Act is making things even worse, where it was difficult for reporters to get in and cover this stuff in the first place.
Well, hello again. This is Chrissy McMahon, and you're listening to Alchemical Connections. And we just heard from several pods presented throughout this past week since the 13th. Actually, I think they were available after my last report. We had the first one was highly radioactive water leaks at Fukushima, then record cesium levels in Fukushima, none 84 sentenced to 35 months to serve 3 years. Second whistleblower, Cries found. There was a pod that I think didn't go through, and we will replay that. That'll be Arnie Gunderson, his podcast for this week. And then we had the Brightstorm.com transcripts, which explained isotopes, which I recorded last night myself. And radiation, it's easy to understand, from our good friend Liam Sheff. And 2 pods about the U.S. sailors filing lawsuits against Fukushima radiation exposure, which are being denied on all counts. It's not a good sight. So as we go to the energy news, I just want to read the highlights. The first web page that opens for today, posted February 19th, is TV. Extremely high levels of radioactive substances leaked Wednesday night at Fukushima plant. 25 trillion becquerels of strontium-90 and other beta emitters estimated to have flowed out. Investigations still underway. We'll listen to that podcast. And NHK, Japan's television show, on February 19th, Wednesday, 2014. Highly radioactive water leaks at Fukushima plant. TEPCO says water containing extremely high levels of radioactive substances has leaked from a storage tank and was found on Wednesday night. The water leaked from a seam near the top of the tank. It traveled along a rainwater pipe and flowed outside the barrier that surrounds the tank. Officials say their investigation is still underway. Bloomberg on February 19, 2014, TEPCO says new leak of radioactive water found at Fukushima site, about 100 metric tons, that'll be 26,400 gallons of water. Beta radiation readings of 230 million becquerels per liter were taken in the water sample collected today near the H6 tank area. About 300 tons of contaminated groundwater seep into the ocean each day. The sample was collected today near the H6 tank area. Why not sample the water from outside the tank it leaked out of? 100 metric tons with 230 million becquerels per liter, 23 trillion becquerels of strontium-90 and other beta emitters, with half generally being strontium-90, about 11.5 trillion becquerels of strontium-90. TEPCO claims 10 trillion becquerels of strontium-90
reshaped by technology.
entered.
From the way we get around.
Okay, my podcast started already, so we're going to stop here to stop that and go back to this. TEPCO claims 10 trillion becquerels of strontium-90 entered the sea from May 2011 to August 2013. The Kyoto News, February 20th, 2014, roughly 100 tons of highly radioactive water leaked. Thursday, they said the same thing, about 230 million becquerels. And the utility believes the liquid has not flowed into the adjacent sea as there is no drainage nearby. TEPCO believes the liquid has not flowed to the adjacent sea yet. A recent special on Japan TV about Fukushima's contaminated water summed up the situation this way. What has become clear is that it's very hard to control radioactive minerals once they get into the environment. So we did play that podcast, and as we go back to the other articles, record level of cobalt-60 detected in groundwater at Fukushima, hundreds of times above any measurement ever published for underground water. That was published February 19, 2014. This comes with graphs. Monitoring at the east side of Unit 1 to 4 turbine buildings on February 18th. February 13th, cobalt-60 at 770 becquerels per liter. And February 17th, cobalt-60 at 750 becquerels per liter, meaning maybe it was diluted because it's mixing with water. And also see update from NHK, record cesium levels, which we just read, and radioactive cesium levels never seen before at Fukushima. New record as amount in groundwater nearly doubles in 24 hours. Officials admit maybe new leak. The IAEA argues resumption of dumping contaminated water in the ocean, all options needed to be on the table. And that was a video that I'm not sure that I was able to process in collecting this information. So as we go on to continue the articles for today at the ENEnews.com Energy News study, daily releases from Fukushima of 100 plus quadrillion becquerels of cesium-137. Early on in crisis seems reasonable. Chernobyl total release was 70 quadrillion becquerels of cesium-137. So that's half of the amount. Recorded at Chernobyl, it's double at the Daiichi nuclear power plant in Fukushima. Comparisons between modeling and measurements of marine dispersion, environmental half-time, and cesium-137 inventories after the Fukushima Daiichi accident, January 2014. The cesium-137 total atmospheric source term varies. that's Schopner et al. 2012, implies a much higher activity, 1,000 to 10,000 parts of becquerels per becquerels, in the total inventory of radionuclides released. Parts per becquerel, petabecquerels, they're equal quadrillion becquerels. So that's more than a million. That's 4 times quadrillion. Michael Schopner, University of Roma, doctoral student of mathematics and physics. This is a PDF in 2012 using the Fukushima nuclear accident as an example. It is demonstrated that it is possible to reconstruct a source term of known location. This is done exemplary on the basis of the 2011 Fukushima nuclear accident. Due to the radioactive and unstable environment on site of the NPP, no reliable assessment of the emissions could have been done. Fukushima's source term can be reconstructed. Source suggests higher emissions than present in other publications. The derived time-dependent characteristics are in reasonable agreement. The comparison shows similar features in the source terms from various isotopes and stations. The problem of source term reconstruction has been reduced to a system of linear equations. The Journal of Environmental Radioactivity, Michael Schopner et al., December 2012, emphasis added. The real source term at the FD-NPP emitted fewer particles in the case of cesium-137 than assumed in the worst case scenario. Based on these results, a source term of 10 to the 17th and 10 to the 18th becquerel per day, 100 petabecquerels per day. That's 1,000 petabecquerels per day. It seems reasonable for, I would believe that's iodine-131. However, these first results suggest a source term not too different from the worst case scenario of 10 to the 19th becquerels per day. That's 10,000 petabecquerels per day. The fact that the 2 remote stations, RN-70 Hawaii and RN-70 Sacramento, California, suggest a lower source term than the worst case estimation, where the closest stations, RN-38 Takasaki, Japan, presented simulations with improved settings, i.e. dry and wet dispositions, resulted in a better estimation of the source term than previous reported. Plastoni et al. 2011. The scenario agreement with the reported values IAEA 2011 for cesium-137 emissions of 10 to the 17th or 10 to the 18th becquerels per day. That's 100 petabecquerels per day. 1,000 petabecquerels per day. Seems to be reasonable, while for iodine-131, even continuous emissions of 10 to the 19th becquerels per day or 10,000 petabecquerels per day could be possible. The author highly acknowledges the support by the National Scientific Committee Technologies of the INFN for the ER-MES projects and the European Commission under the FP7 program for the EU MED Grid project grant RT 246589. PPP acknowledges the support provided by the EU Research and Development Operational Program funded by the ERDF. And I want to make a comment on the iodine-131. Many people are offering iodine tablets for people to take, which I think we heard in the podcast that I recorded last night, that iodine-131 has a half-life of 8 days. So it would only be really feasible at the first emissions. But since this is an ongoing problem at the reactors 1 through 3, because they're the 3 that were meltdown and are still fissioning, then it would make sense to take the iodine on a regular basis. This just puts the iodine into your body so that the iodine-131 cannot find a room to seed itself. So that's how this system works. As we go on to the next article, which is the last, anonymous U.S. government nuclear expert, Fukushima radiation levels were astronomical, nothing containing release of radioactivity. It's an unmitigated, unshielded number. Monitor detected 100,000 sieverts per hour. In the Asian Pacific Journal on February 17, 2014, a U.S. government nuclear expert who was directly involved in the U.S. government's radiation assessment of the situation said, at 100 meters away, the helicopter, was reading 4 sieverts per hour. This is an astronomical number, and it told me what that number means to me, a trained person. There is no water on the reactor core, and they're just melting down. There is nothing containing the release of radioactivity, and it is an unmitigating, unshielded number. Confidential communication, September 17, 2012. To just put an aside on that particular article, it is possible that, not that they're not covered with water, some of them are exposed to air, and that's causing the fissioning, and that they're the beta levels that are being recorded. The beta levels are the direct result of fissioning of the nuclear rods that are in the towers. Now, if people are not aware, the construction of these Daiichi nuclear power plant generators was diabolical. I love that word because it really gives a clear indication of, we understand how this plant was set up on a fault line on the coastline of the tsunami activity, notoriously known for tsunami activity. So now let's go to the construction of the power plant itself. There are 6 located on the Daiichi nuclear power plant facility. Daiichi meaning number 1. They're on 1 through 3 had the meltdown. Number 3, they're observing the steam coming off because of the weather, they say, which is evidence that the steam, there's higher levels of heat being produced, which is indicative of the nuclear fission process. So as we go into the construction of the plant itself, each power plant facility, building, is about 4 stories high. On the top level, on the 4th story, is where they stored the rods. I'm going to assume the spent rods, not the unused rods, but the spent rods were stored on the top. So when the power plant itself exploded as a result of the meltdown, they were shot across the yard of the power plant. Okay, that's not even being talked about for the most part, but anybody who has come across this information, especially in the beginning, would understand that this is part of the process of what we're dealing with. As we go down through the levels, in the basement is the water collection. The cleanup in the number 4 is being done remote controlly. They have electronic collectors that go into the containment to pull out the rods, but they've been so distorted because of the earthquake and damaged that it is possible that some of them in number 3 through 1, or 1 through 3, I should say it the other way, have been damaged, physically damaged. And if they're touching each other, that as well will cause the nuclear fission reaction. Also, they're supposed to be coated with boron and other materials to prevent air exposure, which would create the fission that creates the alpha and beta nucleotides or emissions that are being read that you hear about, the beta emissions. So when you hear the beta emissions, then you automatically know that fission is taking place on some level. Now, they want us to believe when they told us about how they were going to do this cleanup that they're going to pull these rods out of their containment field underwater. As long as they're underwater, they're safe from air exposure, so there's no nuclear fission taking place. Then they're going to put them into a containment pod, and they're going to truck them across the yard. I'm saying that facetiously, across the facility to a holding space. The reason why they're working on reactor 4 is because reactor 4 is not damaged in respect to the core meltdowns of reactors 1 through 3. That would be 1, 2, and 3. So we just read that the levels are double what was recorded at Chernobyl. So we know that there's 3 reactors that are 2 times the radiation emissions, the core meltdown emissions of Chernobyl. Chernobyl was dealt with, they poured concrete over it. They haven't done anything to this effect. What they want to do is create an ice wall, and they believe if they freeze the isotopes in the ice, which is a very costly process, that they can contain it that way to keep it from going into the ocean. But at the same time, they want to dump the spent water. That means the water that they're collecting that's going through the reactors to cool them. They're collecting that, and at the same time, what we read last week is there's a spring that's running through, there's a channel actually through the facility, Daiichi Nuclear Power Plant facility, that runs from the spring to the ocean. So anything that's leaking out of any of the reactors is going through this channel, through the spring water, and being dumped into the ocean that only has what amounts to a felt carbon filter that's supposed to stop the isotopes from entering the water. When I had my interview, I believe it was in January, with Alfred Labramont Weber, his friends, and I believe it was Laura Murray, recorded in air, in flight, radioactive isotopes that were above normal levels, and they believe there's also been above level recordings of isotopes, nuclear isotopes, directly related to the Fukushima core meltdowns and consequent leakage of radioactive water, contaminated water, into the ocean. There's been reports of harm and death of many sea life creatures, from whales to dolphins to seals, starfish, all kinds of fish. They're recording levels on the beaches in California. Not much has been reported in Hawaii. Hawaii's just passed laws to start taking recordings of levels of radiation isotopes. And I want to also put an aside in that yesterday I went to a friend's house, and her son works for NOAA, and he's actually a diver, and he's been recording levels of past contamination of, I guess it was the DDT that was used as sprayed to tone down the bug infestations in forestry, and it wasn't just used on farmland, but I think it was also used in national state forests. So it was sprayed everywhere, just a abomination. So they're still recording the levels up in the Great Lakes, and I had a chance to ask him specifically about Fukushima, is NOAA doing any recordings on the isotopes, and I specifically asked about cesium-137 and 134, and he just looked at me and says, "Oh, well, you seem to know a little bit more about it than he did." I'm not going to diverge any names here to protect the innocent, really, because he made the comment, and it didn't dawn on him, because for whatever reason he wasn't concerned about Fukushima in any way, shape, or form, but that there isn't any recording being done of any isotopes that he's aware of in his department or with his dealings with NOAA. So I just wanted to put that out there. So we know the National Oceanic and Atmospheric watchdog for the U.S. So just want to let everybody know there's been a concerted effort to not record any levels. And also we learned last week a little bit about Japan's state secret law that was passed December 6th. So we just heard from Tom Hartman. He's been doing some things regarding Fukushima and the sailors on the USS, the Reagan. But Arnie Gunderson, who is the author of the Fairwinds Energy Education website at fairwinds.org, is the podcast we're going to hear next. And then I think we're going to go into transhumanism, because a lot of people are talking about geoengineering, which I believe not only is it considered a extinction level event, but also could be very easily considered geoengineering. And I also played a couple pods of other nuclear power plants in the United States that are also showing high levels of isotopes being dispersed into the atmosphere. So it doesn't seem like that my podcast is already put up. So without further ado, we're going to listen to the most recent podcast from Arnie Gunderson from Fairwinds.org, his energy education website. And maybe we'll pause after that and continue the rest of this ENEnews.com article, which is the anonymous, well, maybe we'll finish it. Anonymous U.S. government nuclear expert, Fukushima radiation levels are astronomical, nothing containing release of radioactivity. It's an unmitigated, unshielded number. Monitor detected 100,000 sieverts per hour. And an email from Defense Threat Reduction Agency on March 17, 2011. Please take note of the new containment monitoring reading. So these are older articles which you can find information on the website. I'm sure there's so many people now are recording it. We have Rad Chick, her website. She has a free Facebook webpage, which is more current events, and that's, I guess, where I got the idea to do. This is a Fukushima current events, because it's the most recent in the last 7 days of articles and news reports being presented. So without further ado, we will go to
I'm Arnie Gunderson of Fairwinds. Nuclear containment systems were designed and built as the last line of defense to protect the public from radiation releases after a nuclear accident. During the first week of the triple meltdown at Fukushima Daiichi site, It was obvious that all the General Electric Mark I boiling water reactor containment systems failed to operate as designed. They did not contain radiation. Since the Fukushima Daiichi tragedy occurred almost 3 years ago, Fairwinds Energy Education has discussed the issue of containment failure many, many times. For a detailed explanation of the Fukushima containment failures, please see the speech I gave on March 11th, 2013 to the New York Academy of Medicine. The link is on the site right below this video. 2 weeks ago, Tokyo Electric released some strange data claiming that they had discovered a new leak in the containment system on Fukushima Daiichi Unit 3. First, what do we know about this leak from TEPCO's own information update? TEPCO stated that a robot inside Fukushima Daiichi Unit 3 detected a water leak. The water was viewed on the robotic cameras, and it was a stream. It was about a foot wide, and it was running across the floor of Unit 3. TEPCO then measured the temperature of the water at 20 degrees centigrade or 68 Fahrenheit. And because the air temperature was 7 C or 42 Fahrenheit, the water, which was more than 20 degrees hotter, obviously this could not be rainwater. Next, TEPCO measured the water's radioactivity level and found that the water stream was highly radioactive. TEPCO now believes this could not be rainwater simply because it's warm and highly radioactive. Let's be clear about the technical forensics here. Temperature is not a reliable litmus test for the stream of water. Rainwater could have fallen and risen in temperature due to contact with hot surfaces. The same is true with the radioactive content. Since Unit 3 had radioactive material explode far and wide, and because TEPCO has yet to begin the cleanup of the radioactive debris inside the containment, the rainwater could have come and picked up radioactive contamination that has spread throughout Unit 3's containment system. In nuclear power plant operations, any pathway for rainwater to get inside a nuclear reactor is also a pathway for significant amounts of radioactivity to leak outside into the surrounding water and air. The news release by TEPCO that the rainwater could be leaking inside Unit 3 is a clear admission that Unit 3's containment system is compromised and it's leaking radioactivity into the surrounding water and air. That we know for sure. Second, because the stream was warm and radioactive, the water leaking in Unit 3 either came in contact with radioactive debris spread throughout Unit 3, or it's leaking from the water that cools the nuclear core within the reactor itself. Remember, even now, almost 3 years after the triple meltdown, TEPCO is adding 4 tons of water every hour into the containment system and into what remains of the nuclear reactor core to keep the nuclear fuel cool, because it's highly radioactive and physically hot nuclear fission products that remain from the chain reaction that ended 3 years ago. Third, clearly there are even more problems with TEPCO's analysis of this Unit 3 leak. Where did this leaking come from? TEPCO claims that the leak is flowing from a room that contains main steam isolation valves. These are huge valves designed to close after an accident. It's impossible for water that cooled the nuclear reactor to leak from this location. Let's look at a sketch of a Mark I BWR containment system to determine why it is impossible. The containment is inside a box. That building is called a reactor building. This is the same building that exploded at Unit 3 shortly after the triple meltdown began at Fukushima. Inside that box-like building is the containment system, and it looks like it's an upside-down light bulb connected to a donut. The containment system began to leak as hydrogen gases increased in pressure, and the bolts on the lid began to stretch. You can see this in a graphic Fairwinds developed in 2011 to describe this phenomenon. The containment system meant to protect the public was breached on the very first day, and gases leaked out into the surrounding environment. Within 3 days of the Fukushima catastrophe, Unit 3 blew up. Next, the seals around the electrical wires and the pipes that enter the containment also failed. These seals are made of rubber and they're made of plastic, and they're not designed or fabricated to withstand the high temperatures, the high pressures, or to be in contact with salt water from the ocean that was used to keep the core cool as the accident progressed. Furthermore, the failure of the rubber and the plastic seals is facilitating the leakage of radioactive water into the surrounding groundwater and the environment. Finally, the nuclear core that has melted through the thick nuclear reactor and the reactor coolant pumps have also failed. So whatever water reaches into the reactor flows out onto the floor and never ever touches the main steam piping, as TEPCO claims. Now, these leaking seals in the containment are what establish the water level inside the containment. The 4 tons per hour that are pumped in runs right back out. Let's look at a graphic that compares the location of the leak with the water level inside the containment. This drawing shows that the water level inside the containment is much lower than where TEPCO claims the new leak was found. And we all know that water does not flow uphill. Even more perplexing is the fact that the radioactivity in the leaking water is 100 times less radioactive than the water normally found in the basement of the containment. But it's 100 times more radioactive than the water currently being pumped in to cool the molten remains of the nuclear core. So the question is this: what is really happening at Fukushima Daiichi Unit 3? Since there were so many variables, Ferenc is not going to speculate on the source of what the water leakage is today. But the data shows that TEPCO does not know the source and is only guessing that it might be rainwater and that it might be coming from the main steam isolation valves. For me and other nuclear engineers with whom I consult, this is not a good sign for Fukushima Daiichi site, surrounding environment, or for the people of Japan, because it proves once again that TEPCO is not in control of the situation at the severely contaminated Fukushima Daiichi site. We can conclude that TEPCO does not know if the cooling water on the way to the reactor got sidetracked onto the floor, or if the warm water leaked onto the floor after cooling the reactor, or if the water came from inside the containment, or even if it came from outside the containment. 3 years after the worst industrial catastrophe in the history of the world, TEPCO and the Japanese government still do not have control of the site and the radiological effluents contaminating the surrounding water table, the nearby ocean, or escaping into the air and blowing in the wind. A colleague of mine said that in CSI Fukushima, if there was such a TV show, technicians would collect and analyze samples of water from the reactor floor and from the process pipes and the holding tanks and the vats. The radiological and chemical analysis from these water samples could eliminate many of the possibilities of where the water is coming from and sharpen the focus on the real culprit of the extensive leakage, just like blood typing and DNA tests are performed to target criminals in CSI. I agree with my colleague. TEPCO must think more like CSI Fukushima and less like a bystander in this catastrophe that they and General Electric created by building and operating these Mark I boiling water nukes. I'm Arnie Gunderson, and I'll keep you informed.
Airborne plutonium detected outside troubled U.S. nuclear facility. We did play a podcast pertaining to that. It also said February 19th, traces of radiation have been found approximately half a mile northwest of the waste isolation pilot plant Tests by the Carlsbad Environmental Monitoring and Research Center showed evidence of a trace amount of americium and plutonium on an air filter Wednesday afternoon. CEMRC Director Russell Hardy said even though trace amounts of radiation were detected between Tuesday and Sunday, it's important to note that radiation levels have been very low and are well below any level of public and environmental hazard. It's important to know that all nuclear power plants also emit isotopes. At what levels is never told. It's more or less like trade secret, and they have what amounts to these secret rights to release these substances without having to report them to the public. All part of the deregulation back in the Reagan era, I'm not sure. I'll have to look more into this. But then the press release from the Carlsbad Environmental Monitoring and Research Center, the CEMRC, February 19, 2014, the levels detected during this time period were higher than normal background levels of radioactivity from transuranic elements commonly found at the sampling station. Thus, their presence during this specific time frame appears to indicate a small release of radioactive particles from the WIPP underground exhaust shaft in the brief moments following when the radiation event occurred and when the WIPP ventilation system shifted to the filtration mode. So, the AP said on February 19, 2014, radiation is in the air a half-mile from the site. Radioactive isotopes, americium and plutonium. Hardy says the levels are the highest ever detected at or around the site, but are far below those deemed unsafe by the Environmental Protection Agency. And we all know that the EPA lowered the levels. And I will get that information in a moment. The readings came after the radiation alert over the weekend from an underground sensor at the site. Hardy says readings will be completed next week on filters collected from that underground sensor and an air monitor closer to the plant. Initial E&E report from Sunday, alarm after unusually high radiation levels at U.S. nuclear site. Government, we've never seen levels like we're seeing. I can't tell you the amount. Could be plutonium, unclear how much radiation released. Unprecedented event. And there was a video with that. And also see the LA Times, experts say radiological process may have forced mineral out of container at U.S. nuclear site. Could be a mess. Officials saying little about extent of problem. Levels remain too high to let in non-essential personnel. Air monitors not allowed to collect filters. So this is at the waste isolation power plant. And I'm not sure exactly where that is. So as we take this little break, we will come back with you. Hello, this is Chrissy McMahon, and before we get into any more podcasts, I did find the information, and I think it's important that I start with the waste isolation power plant. Is the world's third deep geological repository after the closure of Germany's repository for radioactive waste, Mausoleum, and Schlotz asked two salt mines licensed to permanently dispose of transuranic radioactive waste for 10,000 years that is left from the research and production of nuclear weapons. It is located approximately 26 miles, 42 kilometers east of Carlsbad, New Mexico, in the eastern Eddy County, in an area known as Southeastern New Mexico Nuclear Corridor, which also includes the National Enrichment Facility near Eunice, New Mexico, the Waste Control Specialist Low-Level Waste Disposal Facility just over the border near Andrews, Texas, and the International Isotopes Incorporated facility to be built near Eunice, New Mexico. it just goes on to explain, this is a Wikipedia page, the early conceptualization and facility placement. The United States Department of Energy, the DOE, began studying sites for construction of the waste isolation pilot plant near Carlsbad, New Mexico in '73 after the abandonment of a similar site in Lyons, Kansas. The Kansas site, tentatively selected by the Atomic Energy Commission in 1970, was deemed unusable due to unmapped oil and gas wells located in the area and local and regional opposition. These uncharted wells were believed to potentially compromise the ability of the planned facility to contain nuclear waste. As a result of these concerns, and because of positive indications of interest from a southern New Mexico community, the DOE relocated the site of the proposed nuclear waste repository of the Delaware Basin salts bed located in New Mexico. Exact placement of the construction site in the Delaware Basin changed multiple times due to safety concerns. Brine deposits located below the salt deposits in the Delaware Basin posed a potential safety problem. The brine was first discovered when a 1975 drill released a pressurized deposit of the liquid from below the repository level. Constructing the plant near one of the three deposits could, under specific circumstances, compromise the facility's safety. The brine could leak into the repository and either dissolve radioactivity or entrain particulate matter with radioactive waste to the surface. The containment brine would then need to be cleaned and properly disposed of. There is no drinking water near the site, so possible water pollution is not a concern. After multiple deep drilling, a final site was selected. The site is located approximately 40 kilometers east of Carlsbad. They obtained congressional approval in 1991 that a federal judge, ruled before any waste, even for testing purposes, was sent to the facility, Congress must approve the WIPP. This indefinitely delayed testing until Congress gave its approval. The 102nd United States Congress passed legislation allowing use of the WIPP, and the House of Representatives approved the facility October 6, 1992, and the Senate passed the bill allowing the operating of the facility October 8th of the same year. The bill was met with much opposition in the Senate. Senator Richard Bryan fought the bill based on safety issues that concerned a similar facility located in Nevada, the state for which he was serving as senator. His efforts almost prevented the bill from passing. New Mexico Senator Peter V. Domenici and Jeff Bingaman effectively reassured Senator Bryan that these issues would be addressed in the 103rd Congress. The final legislation provided safety standards requested by the House and an expedited timeline requested by the Senate. Final legislation mandated by the Environmental Protection Agency issued revised safety standards for the facility. It also required the EPA to approve testing plans for the facility within 10 months. The legislation stated that the security standards mandated that the bill were only applicable to the WIPP in New Mexico and not the other facilities in the United States. This clause caused Senator Bryan to oppose the bill, as he wanted safety standards mandated by the bill to apply to the facility in Nevada as well. Final certification in 1994, Congress ordered Sandia National Laboratories to begin an extensive evaluation of the facilities against the standards set forth by the EPA. Evaluation of the facility continued for 4 years, resulting in a cumulative total of 25 years of evaluation. In May 1998, the EPA concluded that there was reasonable expectation that the facility would contain the vast majority of the waste interned there. The first nuclear waste arrived at the plant March 26, 1999. This waste shipment was from Los Alamos National Laboratories. a major nuclear weapons research and development facility located north of Albuquerque, New Mexico. Another shipment followed the April 6th of the same year, 1999. These shipments marked the beginning of plant operations. As of December 2010, the plant has received and stored 9,207 shipments, 72,422 cubic meters of waste. The majority of this waste was transported to the facility via railroad or truck. The final facility contains a total of 56 storage rooms located approximately 650 meters underground. Each room is 100 yards in length. The plant is estimated to continue accepting waste for 25 to 35 years and is estimated to cost a grand total of $19 billion. And there's a picture of the waste shipment casks, and they're marked as radioactive. And I'm just wondering because a few years back I saw huge tanks. I'm not sure what they were being used for. Were being shipped through Schuylkill County or Bloomsburg, actually, and I'm not sure what county. I'm not sure if that's Columbia, but they stopped traffic and they blocked up the roadway because they didn't fit through the streets. So it was never announced what exactly they were, what was being transported. So it's kind of diabolical. So as we go from that, I found an article, the Department of Nuclear Engineering, University of California, Berkeley, confirmed EPA rigged RadNet Japan nuclear radiation monitoring equipment submitted by Anonymous on Tuesday, 2011, looks like June 21st. Berkeley Radiological Air and Water Monitoring Forum. The EPA recalibrated rigged Japan nuclear radiation monitoring equipment, causing them to report lower levels of radioactive fallout after the Fukushima nuclear meltdown than what was detected before the disaster. I recently programmed an application to pull all the EPA radiation monitoring graphs for all major U.S. cities and compiled them into an easy-to-use web interface. Of course, we took the data being reported with a grain of salt under the suspicion that the feds were fiddling with the results. Now, an investigative report looking into why much of the EPA radiation monitoring equipment was offline when the Fukushima nuclear meltdown occurred reveals that EPA has in fact rigged radiation monitoring equipment to report lower levels of radiation. RadNet or SADNet, ? The EPA's failed radiation detection system. RadNet, the EPA's frontline radiological detection network, is severely flawed and suffers from maintenance and reliability issues. The lack of consistent data and the number of units offline, a techie term for broken, at the time they were most needed, shows that the EPA was not prepared for this emergency. Besides this, the fact the broken system left us all unprotected. The confusion, apprehension, and fear witnessed as by people try to wade through the incomplete and inaccurate data online is evidenced by an exchange on the UC Berkeley website over the RadNet graph. Then it just went on to EPA historical data is available via the RadNet query interface. It was not verified on June 21st, 2011, 8 hours later. You can generate beta or gamma graphs similar to those shown in the Japanese emergency webpage via the RadNet query interface, and it gives a link. You can select beta gross count rate or any all of the gamma ranges, the measurement, end date, time, the date range, the city you want to see, and click submit. You can generate graphs from the subsequent result page. The query is limited to 400 results at a time. Rigged, if being used in its most negative connotation, is a bit of an exaggeration. I see no proof that anything was rigged in that sense. If you think about it, why would anyone rig the results to show a very obvious drop? If I were to rig something, I'd keep the levels constant with previous reports. However, at this very least, the equipment was not maintained as well as it should have been, which apparently requires quick service to provide more accurate measurements. I'm certainly no expert on how the EPA uses their monitor data, but I would hazard a guess, and that's all it is, a guess, that they use the monitors to simply detect upward trends in background levels. Any significant sustained increase is investigated, which would include pulling air filters to analyze F used that way. The actual levels reported are less important than identifying the significant increase. I can't even begin to guess how well they normally monitor the data that they are getting. Lastly, while the Sacramento graph looks like something was done to the monitor post-Fukushima, the San Francisco graph shows no adjustments at that time. I don't know if this link will work or not, but here's San Francisco from 3/1 to 3/17, 2007. If it doesn't work, you can generate it from the query page. And that was posted by VB, not verified. So this is just the Department of Nuclear Engineering, University of California, Berkeley monitoring page with anonymous posts and subsequent comments that I found. And that was basically the bulk of it. I tried to find something that was up to date, and here's 4/27/12 on Forbes. Inspector General faults EPA radiation monitoring. 20% of the EPA's stationary radiation monitors were out of service last year at the time of the Fukushima nuclear accident, leading the U.S. Office of the Inspector General to conclude that the EPA's RadNet system is vulnerable and managed with less urgency and priority than it deserves. Broken monitors, parts shortages, relaxed quality controls, and a lack of volunteer operators left 25 of the EPA's 124 stationary monitors out of service for an average of 130 days at the beginning of the Fukushima disaster. According to the OIG, 2 monitors in Harlingen, Texas, and Raleigh, North Carolina were out of service for more than a year. EPA's RadNet program will remain vulnerable until it is managed with the urgency and priority that the agency reports it to have to its mission. The Inspector General concludes in an audit released last week, and this was for 2012, April 2012. If RadNet is not managed as a high priority program, EPA might not have the needed data before, during, and after a critical event such as the Japan nuclear incident. Such data are critical to determine levels of airborne radioactivity that may negatively affect public health and the environment. The RadNet system consists of 124 stationary monitors distributed throughout the United States and 40 mobile deployable monitors. When operating properly, the monitors consistently sample the air and send data to the EPA headquarters, where computers monitor the data and alert officials to unusual readings. The monitors also serve as collection stations for precipitation, drinking water, and milk samples. In accordance with the Patriot Act, EPA has identified the RadNet system as critical infrastructure for Homeland Security. But many monitors were in critical condition when fallout from the Fukushima nuclear disaster began drifting across the United States and its territories last March. According to the audit, at the time of the Japan nuclear incident, 25 of the 24 installed RadNet monitors, or 20%, were out of service for an average of 130 days. The service contractor completed repairs for all monitors by April 8, 2011. In addition, 6 of the 12 RadNet monitors we sampled had gone over 8 weeks without a filter change, and 2 of those for over 300 days. Because EPA managed RadNet with lower than regular priority, part shortages, and insufficient contract oversight contributed to extensive delays in fixing broken monitors. In addition, broken RadNet monitors and relaxed quality controls contributed to the filters not being changed timely. Out-of-service monitors and unchanged filters may reduce the quality and ability of critical data needed to assess radioactivity threats to public health and the environment. EPA officials agreed with most of the recommendations in the audit and said most will be implemented this month, but they disputed any assertion that the system underperformed or was inadequately managed. The EPA is particularly concerned about the statements concerning relaxed quality controls, excuse me, since the EPA contends that this is inaccurate. EPA cannot assign volunteers or enforce expectations upon them, McCarthy and Hooks write in their response to the audit. Instead, EPA seeks volunteers without compensation for their time and effort. EPA also provides recognition, such as letters of appreciation for their supervisors, for their service in an effort to maintain a good relationship with our volunteers. Maybe next week we can get into radiation levels that are being recorded in foodstuffs. So we've already done air, we've already done water. In a sense, we've also talked about the positioning of the Daiichi nuclear power plant, its construction. We've talked about secrecy laws passed last week or the week before by Japan in comparison to our Patriot Act and the NDAA and other laws that need to be addressed, but not specifically in the Fukushima current events forum. I like to keep this strictly to radiation levels and what's happening across the country here in the United States, as it also affects us because of the way the wind blows. So as we continue to monitor, we will look at all these different sources, and we want to thank Energy News, enenews.com, Rad Girl, any other sources that we can find providing information.